Lesson 10, Operational Amplifier. Section 10.4. Current mirror. One of the two circuits that made the removal of RE possible is a current mirror. The basic current mirror consists of two transistors, TR1 and TR2. Both bases are connected, and the collector and base of TR1 are connected. TR1 is equivalent to a diode. Since the collector is connected to the base, the voltage VCE is the same as the forward bias voltage VBE of the base emitter PN junction. TR2 works as a current-controlled current source. The amount of this current source is controlled by I1, thus, I2 is equal to I1. I2 mirrors I1, so this circuit is called a current mirror. A current mirror is a simple way to implement a current source. In this circuit, I2 is equal to I1, I1 is given by VCC minus VBE over R1. So, I2 can be controlled by R1, independently of R2. Experiment 10.4. Pause the video and follow the instructions. This is to measure how well IC2 mirrors IC1 at R2 equals 510 ohms, and 1 kilo ohms. These are the waveforms of, from top to bottom, VCC, VC2E, and VC1E. This is the case where R2 equals 510 ohms. From these data, IC1 and IC2 are calculated using these equations respectively. These are the results. The horizontal axis represents VCC, and the vertical axis represents IC1 and IC2. The results showed that IC1 and IC2 coincided well with each other. These are the results with R2 equals 1 kilo ohms. It was found that IC2 mirrored IC1 fairly well, independent of R2. Let's theoretically examine how similar I1 and I2 are. Assume that the characteristics of the two transistors are identical. Then, IB1 equals IB2, because VBE is common to both transistors. IC1 has this relationship with its base current IB1, where HFE is the DC current gain of the transistor. Then, it changes to this relationship with IB2. According to Kirchhoff's current law, at the collector of TR1, this relationship exists among these currents. From these equations, it is found that I1 is related to IB2. Then we have this relationship between I1 and I2. In exercise 3.4.1, HFE was 213. This value is very large compared to 2, thus I1 is almost equal to I2. Because the characteristics of TR1 and TR2, used in experiment 10.4 were not identical, there was a slight difference between I1 and I2 in the experimental results. Section 10.5. Current source in emitter circuit. What will happen to VCG, if RE is replaced by a current source IE? Exercise 10.5. This is your homework. Pause the video, and answer the problem. Experiment 10.5. Construct this circuit. The part of the circuit encircled by the dashed dotted line is a current mirror. TR3, which is inserted into the emitter circuit of TR1, functions as a current source. The emitter current IE is regulated by the resistor RCM. Pause the video, and follow the instructions from steps 2 to 5. This is to measure the effect of the current source on the output of amplifier VCG. These are the results. The orange line is the input Vs, and the purple line is the output VCG. VCG showed little change. The current source in the emitter circuit made VCG independent of Vs. The operating point Q is determined by the current source. In this circuit, IB is given by this equation. Since IE is constant, IB cannot be changed by Vs. Thus, VCG showed little change. This means that even if we apply the bias voltage VCC, this bias does not determine the operating point Q. This is a bias-free circuit, but it is not an amplifier. The author of this material is Takeshi Furuhashi, Professor Emeritus, Nagoya University. If you have any questions, send emails to this address.